Moving forward with more formulas that we're going to need in order to solve trig equations and verify trig identities, there are two in this lesson, the power reducing formulas and the half angle formulas. So first we'll start talking about the power reducing formulas. So these formulas are substitutions. We substitute them in anytime we see even powers of sine and cosine. For instance, down here, for sine squared, you can substitute, since it's equal, anything that's equal means you can replace one thing with the other. And what this does is this reduces the power from having a power of 2 to a power of 1. And all of these, sine squared, cosine squared, and tangent squared, all of these power reducing formulas make use of the cosine of the double angle of theta, or of x, of the angle measure. So you can see all of those are cosine of 2x. So make sure these are in your notes. For sine squared of x, the power reducing formula is 1 minus cosine of 2x over 2. For cosine squared of x, the power reducing formula is 1 plus cosine 2x over 2. That's the only difference, is the minus here for sine squared and the plus here for cosine squared. Otherwise, those two power reducing formulas are identical. And for tangent squared of x, it shouldn't be any surprise that it's going to be sine squared of x over cosine squared of x, and of course 1/2 over 1/2 has a value of 1. So as long as you know the power reducing formulas for sine squared and cosine squared, you can use the algebra of those to find the power reducing formula for tangent squared, which is 1 minus cosine of 2x over 1 plus cosine of 2x. So let's work an example using those power reducing formulas. We want to express sine squared of x times the cosine squared of x in terms of a lower power, the first power of cosine. So we're going to use the formulas for lowering the powers repeatedly. After the first substitution, everything beyond that is just going to be algebra. This is where it's really important that you use parentheses, that you are careful to use as many steps as you need to clean this up algebraically. So we know that the sine squared of x, its power reducing formula is 1 minus cosine 2x over 2. And the cosine squared of x, its power reducing formula is 1 plus cosine 2x over 2. Now we have a numerator times a numerator and a denominator times a denominator. Hopefully you can look at the numerators and you can see that when you multiply that through, that's going to be the difference of two squares. So we have 1 minus cosine squared of 2x over 4. If we take this 4 and make it a common denominator to those two terms, then we'll have 1/4 minus 1/4 times the cosine of 2x squared. And then we're going to use the power reducing formula for cosine squared. And notice it's 1 plus cosine of double the angle that we start with. Here we started with the angle 2x, so now the angle measure is 4x. So remember, we're trying to show this in terms of the first power of cosine. So we make another substitution, and then we distribute the 1/4 and the 1/2. So negative 1/4 times 1/2 is negative 1/8, and negative 1/4 times 1/2 cosine 4x is this term. And now we're going to get a common denominator amongst all the terms. 1/4 minus 1/8 is a positive 1/8. That's all that's happened in that step. We factor the 1/8 out, and we have done what they said to do. We have shown this or expressed this in terms of the first power of cosine. So there's an example for the power reducing formulas. Let's talk about the half angle formulas. Sometimes we have angles for sine, cosine, or tangent where they're not those pretty useful exact value angle measures. They're not pi over 4, they're not pi over 6 or pi over 3. Sometimes they're pi over 12 or pi over 8. And so we use these half angle formulas to change into a known or exact value angle measure. So for instance, let's look at cosine. The cosine of the angle u, which is going to be an exact value angle measure, divided by 2 equals plus or minus the square root of 1 plus cosine of u over 2. Now, we can look, let's say that they ask us to find the cosine of pi over 12. And we don't have our calculator, and pi over 12 is not an exact value angle measure. But we recognize that pi over 12 is pi over 6 divided by 2. Here's the algebra that goes with that. So pi over 6 divided by 2 is pi over 6 times 1/2. That makes, in this instance, that makes u pi over 6. And if we know what u is, then we do have an exact value angle measure, and we can turn that into the side ratio that we know for cosine. So make sure that these formulas are in your notes. The sine of u over 2 is plus or minus the square roots of 1 minus cosine of u over 2. The 2 is under the radical, so make sure you write it that way in your notes. Cosine of u over 2, as we said, was plus or minus the square root of 1 plus cosine of u over 2, again under the radical. For these, the plus or minus comes from which quadrant that we're in. So that's not new information for us either. We know how to do that. Whatever angle measure u is in, that is the quadrant that we're in, and that will give us our plus or minus sign for sine and cosine. Tangent of u, as always, or tangent of u over 2, is the sine value over the cosine value. And so it's 1 minus the cosine of u over the sine of u. Some trig substitution has taken place here. You can see the square root is gone, but some trig substitution has taken place, and so just make sure that this is in your notes. Equivalently, with another trig substitution, we could get this form for the tangent of u over 2. I'm not going to take the time to actually generate why these formulas, especially for tangent, look like they do. I don't think it's going to really add to your understanding. It's just, let's just write these formulas down and know them for being able to do homework. So let's work an example using a half angle formula. Here it says find the exact value of the sine of pi over 8. Well, we recognize that since pi over 8 is half of pi over 4, that the u that we are using in the formula is pi over 4. The u that's in the half angle formula for us here, as I said, is pi over 4. We're going to choose the plus sign because we're in quadrant 1. So looking back at the formula, the sine of u over 2 equals the square root, for us it's the positive square root because we're in quadrant 1, of 1 minus the cosine of u over 2. So that's all I've done is recognize that u in this situation is pi over 4, and I have replaced u with pi over 4. And so we have this positive square root of 1 minus the square roots of 2 over 2, because that's what the cosine value is. The exact value for cosine of pi over 4 in quadrant 1 is positive root 2 over 2. And so again, this is the formula, the half angle formula that I've just substituted into. So we can clean it up, whatever. I mean, this is fine. We do know that the square root of 4 is 2, so we could bring that 1/2 out front. But either way, here is the solution to using that half angle formula for pi over 8. So that's it. We've seen a couple of examples. You need to know the power reducing formulas for sine, cosine, and tangent, and the half angle formulas for sine, cosine, and tangent. Come to class next time and we'll work some homework problems.